if we talk about a force calculation, when we're talking about the force of gravity, we're talking about an object's weight. Because force of gravity is dependent on the gravity wherever, whatever planet or area that person's in. Earth, gravity is the same everywhere, pretty much. Okay? For our intents and purposes, our gravity coefficient on Earth is going to be 10 newtons of force is pushing down every kilogram of mass. Right? So this is a constant. You will always be given this. This does not change. Okay? Now, if I were to tell you that Miss Dworzak's jar here, okay, of peppermints, right? I like the pink ones. The other ones suck. So here's her jar of peppermints, right? There we go, full of peppermints, pink ones, they're amazing. And I were to ask you, if I told you that she went to the bulk barn and she bought 600 grams of peppermints, what would be the weight of those peppermints? Okay, so if I'm asking you that question, there's a series of steps that you have to use to solve this problem. Say that again.
You have to convert something.
Do you have to convert something here? Survey says?
Yes.
Yes, you do. Because, and I'm going to tell you why. When we look at a force calculation, when we're looking at calculating the weight of an object, force is equal to the mass of the object times the gravitational constant. The gravitational constant you will always be given, but the mass, okay, the units here for this forces are always in newtons. Mass is always in kilograms. And the gravitational constant is always in newtons per kilogram. So if you're given something in grams, can you just put 600 into that equation? No, you cannot, because 600 grams is not the same thing as kilograms. Grams and kilograms are very different. They're both masses, but one of them is a heck of a lot bigger than the other. Okay, so if we remember our actual conversion chart here, we've got gram in the middle, decagram, centigram, and milligram over here. We don't really talk about these guys. Nobody goes and buys 10 decagrams of mints. Just like decigrams, we don't talk about decagrams, we don't talk about hectograms, but we do talk about kilograms. So we basically go, okay, we're basically going from this guy to this guy to this guy. These are our big ones. And we know that this scale is logarithmic, just like the pH scale, where every hop is a power of 10. Okay? So if this is 3 hops, 10 to the 3, 10 to the 2, and 10 to the 1. Now, if you're going from something small to something larger, so if you're going this way, you are going to have to divide, right? So if I say that and I go back to this chart here, I've got 600 grams. So if I've got 600 grams and I want to know how many kilograms that is, how many hops away is that? It is 3 hops, so 10 to the 3. Okay? If I'm going from grams which are smaller to kilograms which are larger, am I multiplying or dividing? I am dividing, right? Right here. So I'm going to have to divide this by 10 to the 3. What is 600 divided by 1,000? 0.6. Now, on your test, the science way of doing this is actually showing me your equation. It is not enough for you to go 600 grams and then go, okay, well, 1, 2, 3. There's my work, miss. That is a great trick to make things go faster, and it's accepted in math, but in science, the government actually requires you to show how mathematically you got that answer. And unfortunately, moving the decimal is not an accepted method proof. Okay, making waves underneath your numbers is not an accepted proof. It's correct. It's totally right. But you do have to show me that mathematical division. Okay? So if we divide this, we go back here, and I go, force is equal to the mass of my object times gravity. What is the mass of my object? In kilograms. 0.6 kilograms. What is my coefficient of gravity? 10 newtons per kilogram. And just like fractions, if it's in the numerator and it's multiplied by something in the denominator, they cancel out, which is great because what unit am I looking for? Oh, and that's all I'm left with because forces have newtons. They're measured in newtons. So what is 0.6 times 10? 6. 6 newtons. So Miss Dworzak's peppermints have a weight of 6 newtons.